Good afternoon. My name is Jeff Lumpkin. I work on the Power BI team at Microsoft. It's the engineering team, and so I'm always really proud to say that because I'm not an engineer. I was in finance for 15 years at Microsoft as a controller and as an analyst, and so I used our analytical tools quite a bit. A couple days ago, my older son, he's 12 years old, he asked me if I was a data scientist, and I didn't want to disappoint him, so I said yes, but I don't think I really am a data scientist. But I really do like data a lot, and I like to use data to drive organizations forward. My role right now is to meet directly with customers to show them how to use Power BI effectively. So that means I present probably 400 times a year, mostly to very small groups on Power BI, but also I sometimes get big groups like this. I get to travel to very interesting places around the world. So I've been to Iceland and New Zealand and Singapore and Madrid, all over the place working with customers. And so I'm really having a great time in this role. What I'm going to do today is show you how I approach doing analytics and doing discovery in Power BI. And one of the reasons why I have some confidence in this is how often I do it. So I often will receive data sets from customers. They want me to analyze their data in Power BI and show them what Power BI can do with their data. And that means that I need to, as quickly as possible, try and understand the structure of their data, what's important, imagine what those business leaders want to see, and try and put myself in their shoes and present something that is interesting and of relevance to them. So as I said, I'm not technical. Therefore, for those of you who are technical, what I'm going to show you may evoke scorn or pity. Imagine if you're watching someone rubbing two sticks together trying to start a fire and you're holding a blowtorch. It may be, well, what you're going to see today. But I hope that it's still of value, that at least if my very primitive techniques don't add to your skill set, at least the thought process behind those techniques will. So I think the process of creating insight from data, I start at a very high level, meaning what is the strategic perspective? So if I have a data set from customers, what is it that's important to them and what will they want to get out of it? Great. Think about the context in which this analysis is going to occur. So will it be used on a daily basis by an analyst? Will it be used on a monthly basis to drive business reviews? Or this would be a CEO who wants every day just to get an update on what's going on, get the pulse of his or her business. Think about what are the key objectives and the desired outcomes of the analytic, and then who is the audience? So is it base level analyst? Is it a store manager? Is it a C-level person? And all of those come together to help me think about what is the end product that I'm going after. Not so much at the beginning, but what is it I'm trying to produce at the end. So I always start off with these three things: dimensions, measures, and hierarchies. And when you put those three into place, that's when I start to get a lot of value from data. So I spend a lot of time, I think it's pretty common, you spend 80% of your time just working with the data, 20% of the time doing analytics, and I'm exactly the same way. So the first thing I will do is understand what are the dimensions that are included in this data set. So geography, time, product, customer, and industry are very common ones. Then I look at the measures and the KPIs. And these, they're pretty limited in nature. So at least from a finance perspective, there's actual, budget, year over year, variance to budget, variance to forecast, et cetera. And then where perhaps I spend the most time is understanding hierarchies. And a very simple example of a hierarchy is a date hierarchy, where the most granular level, it can be the very second at which, you can be more granular, but the very second at which an event took place, up to a year or a decade, et cetera. So I will build out a hierarchy like that, or a geography hierarchy. So I'll look at an area like Europe and then break it down into Western Europe and then the Baltics, Scandinavia, and then more granular into the 4 Scandinavian countries. So we'll build out hierarchies because to me, they provide a drill down path to start at a very high level, but follow a path down through the data to get down to an actionable data point or a data point where you can make a decision. And so this is where I spend a great deal of time, and I have an example of how I do exactly that. I think there are 4 specific techniques when it comes to data exploration. The most basic one are just looking for patterns and relationships. So what is the relationship between product and geography, or time and variance to budget? Look at trends. Do you start off small and get big, or do you start off big and get small? That alone can tell you a great deal. Comparisons and deviations. So what stands out? If you were at the keynote this morning, one of the coolest things that Patrick Patrick showed was the quick insights right from Power BI Desktop, where what changed, or why did this go up, or why did this go down. It was incredible functionality that's now being built right into the tool. And then finally, outliers. What is different than the rest, and why is it different? And so exploration means that you're just spinning through the data, trying to find these things. I may not even know what's significant or not until I really understand that data set well, but at least I can identify what is an outlier and then determine is it important or not. So the next two slides are my favorite slides. I have these up in front of, or right beside my monitors, both at home and at work, because I refer to them all the time. So I think about categories and I think about measures and how to contrast or work with those two. So categories, product, channel, geography, pricing level, etc. Measures are taking numbers against those. So actuals, variance to budget, year over year, etc. And when I'm piecing together an analytic, I focus on determining what these are and which ones are truly relevant for the data set that I'm working with. And then in this one, I'm very deliberate when it comes to, as I'm building out a sheet within Power BI, focusing on a distinct measure or a distinct category. So in this example, we're talking about variance to budget, and I would look at variance to budget from a number of different categories. So variance to budget by product, by channel, by geography, etc. And when you're playing with those visualizations, you can see the relationship that may exist for variance to budget as it relates to product versus geography. Similarly, you can focus on one geographic area, but look at all the different measures about that area to understand its performance. And then after you've done that, then you can start to kind of mix and match. So let's say you want to compare two geographies and understand what is different about them. So do they differ in terms of time, in terms of product, in terms of variance to budget, or year over year, etc. Okay, so drill to detail. These are two very common ones that I mentioned. One is geography, the second is time. These are pretty simplistic representations. But the more that you can build hierarchies and think about what are important hierarchies, the easier it is to get the story out of the data you want to tell. And from an organizational perspective, one of the things that we've done at Microsoft is created whole teams who are devoted towards developing and then maintaining the consistent use of these types of hierarchies. One example is we have a 20-person team reporting directly to Amy Hood, so sitting within finance, but their role is to maintain the KPI data lake for all the KPIs that we use at Microsoft. And associated with all those KPIs are the different hierarchies and dimensions that we use in order to organize the business. So for us, it's a strategically important activity, is maintaining these hierarchies. And whenever I'm working with customers, I urge them to think about if they're not doing so already. So just some guidelines. When I come to build out a dashboard, having done all this discovery, start out with the end. So again, who is your audience? What is the purpose? What meaning do you wish to get out of it? How often will this be viewed, etc. Think critically. One of the first roles I had when I left finance and joined the engineering team was to critique submissions from partners on Power BI, examples of Power BI work that they had done that they wanted to go up onto our partner website. And some examples of poor critical thinking, they were abundant in many submissions. One example is, let's say you have a column of actuals and a column of budget. From there, if you wish, you can have a column of variance to budget. And then next to that, you can have a column of variance to budget percentage, where you divide the variance to budget by the budget. So then you would have a column of percentages. One very common mistake that I've observed is people will want to understand that column of variance to budget percentages, so they will sum the column. And just from a mathematical perspective, it absolutely does not make sense. So think really critically about what your measures are. Do you wish to use a calculated column or a calculated measure? And just do a gut check. Does this make sense to me? Look at the number, think more theoretically, but also look at the hard number itself and give yourself the chance to decide, is this worthwhile? Does it make sense? Or am I misleading in some way? Match the graphic to the data. So some graphics work very well with data, some graphics do not. If you have, let's say, 50 categories, probably a pie chart is not the right graphic to be using. So spend some time thinking about that. Always go for simpler as opposed to more complex. Put fewer elements on the sheet. Make sure that they are simple. That, to me, is where the drill down capability of Power BI becomes very useful. So rather than showing 50 countries, I would show 4 time zones and drill from time zone to area to region to country. and so give myself that drill down capability. Be consistent with fonts, with colors, with sizes. Make it easy for your audience to consume and understand what you're doing. Because, I mean, really, Power BI is communication, right? You wish to communicate something. Make it as easy to understand as possible. Edit interactions is, I think, kind of a hidden feature, but I'll show you what that looks like. But it allows you to change the way that visualizations work with each other on a sheet. And that change can be really important in terms of communicating certain messages. Formatting drives understanding. So I was in business school. In my business school, we were in teams of 6, so we spent every day for 9 months the first year working together, which meant there was a lot of interaction. And one of the smartest person on our team did not format at all. So we were using Excel spreadsheets, but she would have a value, a whole number, and then 15 decimal points coming after that number in her spreadsheet. It was illegible, and it made me insane. So the more that I work with data, the simpler I want to make my formatting. As simple and understanding as possible, because if people can't even read what's on your sheet, you've lost them right from the very beginning. So any questions based on this? I know it was kind of fast. Nope, okay. Then I'm going to move into my first demonstration. So I'm going to use an Excel file as my data source. So here we are in Power BI Desktop. This is the visualization pane. And what I'm going to do is I'm going to take this Excel file. I'm going to show you how I will bring it into Power BI Desktop and explore with it and build up a data model in order to drive better exploration and understanding. So to get there, I'll come to Get Data from the Excel file, and it will be this DE source table. So I open it up, and it's a pretty simple table. I have some dimensions. So I have country, month, forecast planning level. So this is real Microsoft sales data. Planning level is essentially pricing. I have a column for product called Rev Sum, and then customer segment, which is different customer segments, and then 3 data columns, so actual, budget, and forecast. I want to look and make sure that everything's coming in the way I wish it to be, so numbers are numbers, etc. It looks good, so I close and apply. Now it's all coming down into the desktop. And I'm just going to write some very simple DAX formulas. So the first will be summing up the actual column. Okay, and then I'll just sum the budget column as well. And then a third will be the variance to budget, which is actual minus budget. Okay, then 2 very simple visualizations. So we'll get a bar chart with actual sales by country. And then the next will be a bar chart with the variance to budget by month. Okay, so a couple things to note here. One, there are huge variations between, say, Poland and Norway. And then secondly, a couple things, huge variations by some months, but also this is coming out alphabetically as opposed to the order of the month. So a couple changes that I want to make. So I'm going to save this, and I'm going to call it DE Sales. And then the first thing I do is publish this out to the service. So I'm going to take it from here and publish it up into my workspace. And you guys probably know it takes the data set and this very simple report that I've just built, and it's going to move it up to the service. Okay, so I follow the link up here. Now, instead of doing anything within Power BI, because I'm a finance guy and an Excel guy, I'm going to use this functionality called Analyze in Excel. So what this does is it opens up this Excel file for me, but I have a live connection back to the underlying data set. And so now what I'm going to do is use a pivot table to understand my data, because I just want to be able to pivot through data. So I'm going to get actual and budget, and then just pull in country. Okay, and then I want to format this quickly. And then I always will change the chart type to pivot table options, and then change it to the classic pivot table. Okay, and so now I'm going to have country with all the countries down below it. So I'm going to take these countries and look at them. I'm going to bring it over to a new sheet. Okay, and when I look at this, I'm just doing data discovery now. So I see a mix of countries from different regions. Austria and Belgium are from Western Europe, while Bulgaria is from Eastern Europe, and Canada is from North America. So I'm going to make a table right here. Okay, and I'm just going to classify these. So we have Western Europe, and I'm just going to get all the Western European countries. And if I miss one, please call it out for me. Okay, so that looks pretty good. So then I'm going to use a sort, and the rest of these are going to be from Central and Eastern Europe, except for Canada and the US from North America and from North America. So then, if this is area, then a final one would be time zone, so TMZ, and I would say this is from Europe. And I'm always thinking, is my data set complete or incomplete? So I would call North America the Americas, because perhaps countries from Central and South America might come into this data set as well, and I want to be able to cover them. So I'm building out, this is a dimension table now. So this would be the one-to-many join, and then these are the higher dimensions. Taken to its conclusion is I would do this with all of these dimensions in my original table and produce all the different dimension tables that I need. So here's the original table, and then these are the dimension tables. So my geography dimension table, and then I have a snowflake table right here, one for time, so I did the same thing for the months, and you can see that I ordered the months, so I created this column called order M, standing for order month, a date, quarter, half, and year, and then same thing for product, for business group, and for pricing level. Okay? So having built all of these dimension files, I'm now going to come and make a second Power BI file. So get a new, and this one I'll be hitting now the original data set plus all those dimension tables that I just built out. Because now I've created an ability to drill down to very granular levels through my data. So getting data will bring me to Excel. Okay, and I'll pick the sales table first, and then geography, area, product, time, pricing level, and subsegment. So all these come in, and let me edit them first. Two things I'll check very quickly. One is are my numbers numbers? So that'll be in the sales table, and they are. And then the second is I'll come to the date table and make sure that the dates are rendering the way I wish. So this stays a month. This is an actual date. So now I'm ready to close and apply. It's creating the data model for me on the fly. Because I have some column names that are similar, it's going to create some duplicate joins that I need to manage. So I'm going to take out this dotted level join and this one. So then I have product to BG. Okay, so now it looks like I have a valid data model. I'll spend a lot of time making sure that the data model works and functions. Many times when I receive files from other people, there are those dotted line joins. This means it's a non-functioning relationship between the tables. Make them very clean. As a best practice, I will always make these, not always, but most of the time, make them cross-filter directions single as opposed to both. And the models just seem to work better that way. So now I'll go back and write the same measures that I just wrote previously. So we have actual is the sum of the table name and the column name. Let me pin that. Okay, the new measure is budget will be the sum of the table name and the column name. Variance to budget is actual minus budget. Whoop. Sorry? Oh, I didn't? Did I miss that? Oh, that was horrible. Thank you. Okay. Okay, so now we'll get variance to budget. And then the last one, variance to budget percentage. Okay, and then I'll just format this as a percentage and make this whole number. Okay, so now I'm going to build out my first sheet, and this will be using those principles that I talked about. So I'm going to focus on actual sales and variance to budget. So the first thing I want to do is just get those 4 measures that I've just written: actual, budget, VTB, VTB percentage, make it a card. So I'm looking at hard numbers. So we have 4 billion in sales, and for this I just want to filter to Western Europe. So I'll pull in area and filter it down to Western, and we get to 980 million in sales. So for my first visualization, I'll have a bar chart with actual sales by country. Okay, pull it up here, resize it a bit, and add data labels. Okay, now to continue, I'll pull in variance to budget and take out actuals. Then coming down, change it to a column chart and bring in some more dimensions. So we'll have fiscal quarter sales, and then pricing level underneath that. And what I'm doing is creating a drill down path here, product below that, and lastly will be customer segment. Okay, then this will be variance to budget by pricing level, and I want to put pricing level to the top then. Okay, and then the last is variance to budget by product. And then I'll make these a little more interesting. So this will be a tree map, and here is a waterfall chart. All right, so now, let me sort it. Okay, so now I have the sheet, and it's a number of the things I spoke about earlier I think are visible here. So one, it's pretty simple. Six visualizations focusing on variance to budget or budget with the dimensions that I think are most important. So in this instance, geography, time, pricing, and product. These are all connected, so there's no code to connect these visualizations. When I select Q4 here, now we're just looking at Q4 data. Now the edit interactions functionality that I talked about is right here. So if I wish, I can change this to a filter instead of a slice. And at that point, the size of the box represents Q4 sales instead of the portion of Q4 sales here within Denmark. And so spend some time figuring out which works for you and should be used most effectively. So now we're at a point where we can do some data exploration. So if I want to look at Q4, I'm going to see a lot about Q4. If I want to look at a specific country, we can look at Denmark and see how Denmark performed. One that jumped out to me as I explored this data was Ireland. So looking at Ireland, the overall trend for sales has Q4 as the biggest quarter. When we select Ireland, what I saw is that Q4 was smaller than Q3. So automatically, I knew that something strange had happened because for everyone, Q4 is the biggest quarter. So if Q4 is not the biggest quarter here, something strange has taken place. The second thing that jumped out was this negative variance to budget in new business. So new business means new customers bringing new sources of revenue. We look at this very, very closely. To see this miss was disturbing. We wanted to know more about it. So when I selected new business, and came back up to the variance to budget by country, what we saw is that Ireland had the biggest negative variance to budget for new business of any country in Western Europe. So despite the fact that Ireland had the largest positive variance to budget, so here, overall, the largest positive VTB, when we select new business, we see the largest negative variance to budget for new business. This is a pretty significant discovery. Because new business is so important to us, the fact that Ireland had missed was of concern, so we wanted to drill further. To do that, I'm going to expand this, and now I have this drill down path to go from pricing level to quarter to country, from there to product, and then down into customer segment. So hitting the drill down button into new business. The big miss overall took place in Q4, so I want to see what happened to Q4. And there, Ireland jumps out as the miss I expected. Now, one thing I forgot to show originally was this, and that is that selecting new business, Ireland had the biggest negative, but Denmark had the biggest positive. So when we go down further and look by all countries in Q4, a miss jumps out for for Denmark in Q4. Again, something significant for a few reasons. One, Q4 was a bad quarter for new business. Two, our two biggest subsidiaries both missed new business in Q4. Q4 had only ended a month previously when I was doing this review. So a big question jumped out was, do we still have a problem with new business in this fiscal year, given what we just observed in the previous fiscal year? Going one level further, the question that was asked was, is it the same product? So was it one product in particular that was tanking in those two geographies? Going into Denmark, the miss came from server and tools. So that was the server business. In Ireland, the miss came from MOD. That was the office business. And we could take some comfort from the fact that it wasn't one product that was blowing up in Western Europe. It was poor sales performance. I don't know if that we should be happy about that or not, but that's how it ended up feeling. So going down into MOD, the miss came from the commercial business as opposed to the public sector business. And then we can do that same exploration in Denmark into server and tools and see, again, it's commercial. So maybe now commercial is someplace else we wish to explore. If I wanted to take more time with this, I would set up then a commercial drill and understand, is it commercial in a very broad manner, or is it a more of a mix between public sector and commercial? Okay. If I wanted to do more, some of the more recent functionality that I use a lot would be to create a second page, copy in my tree map, and then create a line chart where I have actual sales over time. So I'll pull in pricing level time. Okay, and just get a simple line chart right here. Okay, and now I'm going to copy this twice. Come down and put this right here. Okay, and so this one, maybe you guys have seen this before, but maybe not, but I've been using these a lot. So I can write some DAX, but I'm not a DAX expert. When I do need to write DAX, I'll get on a site like Power Pivot Pro or take one of my 4 different copies of Power Pivot Pro and figure out how to write the formula. But this very recent addition, a couple of months now, is quick measures. So now there are 25 different measures where the DAX gets written for you. So if I want to take the cumulative total, which is here called the running total, I hit it right, hit OK. What did it just do? Oh. And now it writes the DAX formula for me and then puts the measure right into this graph. Then the second one that is awfully simple to do is just a forecast. So I'm going to add a forecast over 6 months with a 99% confidence interval. So now I have a forecast going out. And then finally, if I want to break down this line, I'll go get import an R visualization called the time series decomposition, and then change this one to that visualization. Okay, so just in a minute, I've created these 3 pretty advanced pieces of analytics, and they're all integrated into the data model. So I can work with them very, very quickly. So at this point, now I feel like I have something that I can take and show. So I would now take this, put it up to the Power BI service, and there start to create a dashboard for an executive, say for an executive level dashboard. But this is the approach that I take, is spend a lot of time in this area creating these dimensions. And for me, this is the most time consuming, but also the most revealing. So the drill down example that I showed, to be able to get down to new business, into Q4, into country, that's where the learning really comes from. To understand the story in your data is having those hierarchies available and drillable. Yes?
You imported this particular spreadsheet. It recognized each of those tables as a different table.
Correct. Yeah, so each of the tables has a name, so I name the tables, and it recognizes those as distinct entities. When you create a table, let me come to this one. You come to table design, right there, just call it geo. Yeah. Any other questions? Okay, then I'm going to move to the next demonstration. So this is another real data set. This one is pretty fun. This is consumer packaged goods data set. It is alcohol sales in Washington State, so wine and beer sales. It's 1 million row tables. It's 1 million transactions. So every transaction was recorded at the second in which it took place. And I built up an analytic just to understand what was going on with those sales. I was unable to open the document because it's right there. Okay, so This is Washington State. Again, I went through my exercise of creating different hierarchies. So one of them was the geography hierarchy. So this is Eastern Washington, Western Washington, and what I call the metro area going from north of Seattle down through Olympia. And you can see that the metro area is the biggest in terms of actual sales, while west and east are actually quite close. West is a bit bigger. Here are sales by weekend date. So these are all the different weeks of the data. And then I created this hierarchy to look at top, high, low, and bottom. And it changed the color on bottom for me. So let's call that one yellow. Okay. And so this was pretty interesting. What was really interesting, though, was when I cut things by time. And so here I have as many time elements as I could put onto the sheet. In the middle, I have sales by day. So 3 months of data, daily sales. On the top right are sales by day of the month. So August, September, October. On the bottom are sales by day of the week, Monday through Sunday. Sales by hour of the day. So going from midnight to 11:30. And then sales by day, but split by the 4 regions that I created in Washington. And so to interpret this, there are some interesting things taking place here. One is that there's this big spike in August. We would have to know what that spike is. I couldn't go in front of any person, any audience, and not be able to say what that spike is. Second is I see this big drop-off in October related to this last week in October. And I'm sure there's a relation there. We would want to understand what that is. Sales by day of the week. We have Friday as the biggest day, and then Tuesday as the second biggest day. So as an analyst, it's important for me to not just communicate, what numbers are, but also my interpretation of the numbers, and to be able to express a confidence about what I'm saying. So here, when I see Friday as the biggest day, I think I have a good, solid explanation for that. And people in the U.S., a couple things. One, they're paid on Fridays, so they have cash in hand on Fridays. They can afford to buy beer or wine. Secondly, it's Friday, it's the weekend, so people are more likely to buy beer or wine to consume over the weekend. Now, Tuesday is the second biggest day, and this one is not, I don't have an intuitive answer for this. But a theory could be that they buy on Friday, they'll drink Friday, Saturday, Sunday, Monday, and run out on Tuesday. So they'll buy more on Tuesday. That's one theory. Now, second is down here in the middle. Now, we can see the pattern of people getting up and going to work and leaving work, right? So some people are getting up very early for work at 5 in the morning, many others at 6, and then this very steady increase out to the end of the day, to the 5 to 6 o'clock hour, which is when people leave work to go home. However, there's this big spike at noon. So who's got an answer? Lunchtime, right? One seems, again, I can be pretty confident that's the case, but it does seem weird, people going out and buying booze at lunchtime, right? You have to wonder about productivity in the afternoon. And then here, sales of the day split by region. Every region has a very similar profile with this Friday bump. The one exception is the metro region on top that has this peak on Tuesday. And again, I don't have nothing that jumps out to me as being causal. But one theory that I have is that people in the Seattle metro area have higher incomes than in the rest of the state. So because people here are not living paycheck to paycheck, they have cash on Tuesdays, whereas everyone else is waiting till they get paid again on Fridays. To me, that makes sense, but I have no way to prove that. Now, I want to determine what happened on this spike. So to do that, I created a drill down path to take us down through 10 different layers of the data to get down to 1 row out of 1,000,000 rows if we need to go that deep. So this is the value of building out hierarchies. So I click here on the down. I know it took place in August, so I'm going to click into August, and now I'm just going to follow the biggest spike down. So this is the week ending August 15th. Coming in further, here's the day, August 11th. This is the county, so Snohomish County, where this took place. Here is the town called Edmonds. This is the street address, so now we're down at the store. Now we're down at transactions. So this is 1 row out of 1,000,000 rows, and we see it's 40,000 units, so 40,000 bottles of something. We click into it, and it turns out to be 40,000 bottles of Miller Genuine Draft. Now, thinking about this in context, right? This is the grocery store or the gas station or the convenience store, but no one is dropping $200 for $40,000 bottles at the Circle K, right? That's not happening. So my conclusion is this has to be a data entry error. It has to be. Or, some extraordinary event, but I'm going to treat it as a data entry error until I figure out exactly what it is. So to do that, I come back up here, come back to the report, and now I'm going to come down to the filters and filter out, what am I going to filter out? Hang on. I need to go down further. I need to figure out what I'm filtering. I forgot. Okay, so I will be filtering 3629. That's a transaction ID, is 3629. Okay, so I'll come back up, back here, and in the filter, I will say, is not 3629. When I apply that filter, the transaction is gone. So I got the right number. Okay? So now we can reinterpret this data without this one transaction out of a million and see that a great deal has changed on this page. So one is that Tuesday is now just a normal day. Secondly, the lunchtime spike has pretty much disappeared. And three, the metro area looks exactly like the two other regions in the state. So one row out of a million rows was significantly impacting my understanding of what took place in this business. But because I built out these hierarchies in this way, I could drill down and get a lot of information as I was drilling, but get down to that one row out of a million rows to determine what went on. And this, I think, is a great example of how Power BI can drive discoverability. Yes? I could, yeah, I absolutely could, and that was pointed out to me a few weeks ago. I still like this way, though. But yes, that way just makes it too easy, right? I want to struggle a little bit. But yeah, you're totally right. Yes? Right, yeah. So how do I add a parameter in? The parameterization is being developed as we speak. I think that was one of the things they showed in the keynote this morning, was the ability. I have my own kind of hack method, but it's really a hack. But one way that I've done that is I will create a parameter table where let's say I want to look at if I wanted to increase sales by 15% or 10%, how would I do that? So I create this table going from minus 25 to plus 25% in 5% increments, and then write a DAX formula that allows me to select the average of that whole column of values to create what if. That's one way to do what if scenarios. I haven't found a great method besides what I just did to build out those type of dimension tables, and there may be a way. Yes. Right. Yeah. Yeah. Yes. Yeah. So that's absolutely true. You can do that. So up here in the home view, there's this enter data, and so you can do it here because I'm a yeah. Right. Yes. Yeah. You can do all that because I'm an Excel guy, and so you're totally right. If you're writing code, that's the right way to do it. As I said, I'm an Excel guy. So I can see you're pitying me right now. But for me, because I've had so many years working in Excel, I'm really fast at it. That's the best approach for me. But I think if you can write M and write this in code, that's a great way to do it. So, and the date tables, there's a clearly better way to do it using Power Query than the way I do it, for sure. Yes? Are there grouping capabilities? Yes. Yeah. So you can create drill down hierarchies right within the tool. You just drag one on top of the other. Yeah. And to be honest, I don't do that very much, so I'm not really a master at it. But the functionality exists. Yes. This is using this is using an out of the box. Sorry, right there. This one it's mapped by county, and it's using this fill visualization right here. So there's a standard visualization. Any others? Okay. So my next demo is using Sandance. Does everyone know what Sandance is? No? All right, this is great. So Sandance is a custom visualization. It was produced by Microsoft Research. And so it's right here. And we have a big custom visuals gallery, so I think almost 90 different custom visuals written in D3 or JavaScript. So it's really easy to have custom visuals created for you, or if you know JavaScript, to write it yourself. So Sandance I like a lot because I can pivot through data very, very rapidly. And I went and built up this data set on US counties. So there are 3,145 counties in the US. I have collected over 150 columns of data about each county. So I have the ability to look at a lot of data very, very rapidly. This is the structure of my data table right here. You can see each county, the FIPS code, which is a code assigned to different geographies. And then I have the latitude and longitude for each county. And then here are the 150 columns of data coming from 7 different data sources. So I've used the FIPS code as my key to combine all these different data sets together. Again, I did this in Excel. So here, what we're looking at are all the counties. They're colored by the income per capita in the United States. And so this is XY plotting. This is not a map. It's just plotting on an XY axis. Now, what I like about Sandance is how easy it is to change up data sets. So I'm going to switch from one column to another, going from income per capita to poverty rate. So now, just like that, we're able to see where wealthy people or poor people live in the US. So right here seem to be concentrations of lower or higher poverty rate counties. And then a third metric, which is related, are college graduation rates. So we can look at all 3 of those sequentially. I can also look at all 3 of them together by changing latitude to income per capita and longitude to poverty rate. So now we have this what I feel like is pretty intuitive, is this Nike swoosh almost, going from high poverty to high income. And it should be fairly understandable, is that higher education leads to higher income, lower education rates lead to greater poverty rates. The first time I got to this configuration, I was presenting to 4 colonels from military intelligence. They were based in the Pentagon, and these guys were so fast with that. It was really fun to work with them. So they saw the trend, but they also saw that you could identify outliers here very rapidly. So they asked me what this outlier was, so I highlighted it, got the information about it, and it turned out to be Washington, D.C. So right where these guys came from. And as soon as they saw this, we had this, for me, a very interesting conversation about how military intelligence could use this tool. The big learning that I took from it was that one of the big roles of intelligence is to identify outliers as rapidly as possible and deal with them as rapidly as possible before they blew up on you, for example. So the next group I presented to with this was also a very interesting group. It was from the UN Development Fund. And so I showed them this, which was the percentage of firms owned by women in a county. And the learning I get from this is the more that women can be integrated into an economy, the more prosperous that economy is. So both the World Bank and the UN, they have projects in, let's say, Africa or South Asia, where they are tracking development at the village level. So education, health, business growth, et cetera. And they saw they could use Sandance to track the progress in their own projects in areas like that. So now I'm going to switch data sets and come to a political data set. And we're going to look at the results of the 2008 presidential election by county. So this type of map is pretty common. You can see Democrats were strongest along the East Coast, the West Coast, down here in the Deep South, counties where the African American population was high within that county. And then surprisingly to me when I first saw this was all of these Democratic counties in Texas. Because I understand Texas to be a very Republican state, so when I saw this, it didn't make intuitive sense. When I isolated it and got information about those counties, it turned out to be counties where the Hispanic population was quite high. And so all of a sudden, I could understand why they were voting the way they were. So then I'm going to come back and restore this. And now I'm going to jump ahead 4 years to the 12 election. And my sense is that it became more Democratic, but it was hard to really see. But watch what happens when we come to the 16 election. So when I change the 16 election, particularly here, there's a big change. Right? You see all these counties that switched. Now I'm going to make this even more clear. So I'm going to come back here to 12, and I'm going to change the chart type from scatter to scatter 3D. When I rotate the chart, okay, I have the base layer, and then I have the 11 counties that in 2008 voted Democrat, but in 2012 switched to voting Republican. So out of 3,000 counties, only 11 switched. This seemed really low to me. But when we move to the 16 election, it's a much different story. So it's colored by 16 on the base layer, and now the counties that switched from 12 to 16 are right here. Whoops, sorry, that was wrong. Look how many counties switched. And in those states that Hillary Clinton never visited, right? So Minnesota and Wisconsin, Hillary Clinton never went to because she was so confident that they would vote as they had always voted, Democrat, when in fact they did not vote that way, they switched. So this is kind of one elemental truth about the election. I'm going to get another, just for fun. If you use Sandance and it's the end of the day on Friday and you go out and buy your beer, this is kind of a fun thing to do. Okay, so now I'm going to change to chart type to column, and I need to do a bit of resetting now. So bear with me, please. All right, so within this data set, I created 5 buckets of data based on median income for those counties. So bucket number 1 were the counties with the lowest income. Bucket number 5 were the counties with the highest income. And what I see here is that Democrats did best with those counties in the poorest quintile as well as the wealthiest quintile, but struggled here in this middle income segment. And from a messaging perspective, it is really hard to have a consistent message which makes sense both to the poorest elements of society and the wealthiest elements of society because their interests are just by nature different. So from a communications perspective, Democrats need to think what to do. Now, a third way to look at this is if I change the size of the county to reflect the population in that county. And again, we see that another kind of fundamental truth about the election was that Democrats won in counties with large populations, meaning cities, and lost in small towns or rural areas. So 3 ways that Sandance helped me understand and see what was going on in the election. Now, back to a different data set. So I'm going to come back to scatter, latitude, and longitude. Okay, and now I'm going to change this. This is data from the Center for Disease Control. So I have 2 data sets here. One is about obesity rates. The other, I'll tell you in a minute. So this is where shows where people are obese in the U.S. Down here in the southeast part of the country, changing from 2004 to 2013. We see it seemed to spread a lot, but we saw some spread. Not all that dramatic. Watch this though. This one was quite sad. When I first did this, I was at home. And I showed it to my wife, but I wouldn't even bring my kids in the room. This was so disturbing to me. So this is the fatality rate from drug overdoses across 15 years of data. So going from 1999 out through 2014. And in 1999, the epicenter of drug overdose fatalities was here in Appalachia, so West Virginia and Kentucky, a pretty confined area. Now, I'm going to jump ahead to 2008, and the spread was pretty dramatic. And so you can see it spread pretty broadly. But watch what happens by the time we get to 14. Right? Essentially, the whole country was dying at elevated levels from drug overdoses in 2014, and it's worse in these past 2 years. And I think that if we had been able to look at the data in this way, to evoke the reaction I just got, but with people who set policy, perhaps we could have addressed this problem much more seriously 5 or 10 years ago. And this is, again, one reason why data is so important to me is because I think we can drive a lot of change with it. So I want to bring us back to a slightly happier metric, which is I just want to finish up. I'll just come back to income per capita. Not that big a difference. Okay, so then I have one more. Do I have time? I can't go over? Can I go over, Mark? Sure I can? Okay, all right. So this data set is a completely different data set. Let me find it. Franchising. Okay. So my kids love Power BI. They're 10 and 12. And that may not make sense, but the reason why is I was working at home on a data set from Lego. They came in and they said, Dad, what are you working on? I said, Lego. I said, can we come to your presentation? Because they had visions of walking in and having Lego spread everywhere they get to bring it home. I said, not a chance. But my older son said, Dad, I'm going to do something cool, and they will have to let me in. So he and his brother went, and they got 286 kids from their school to fill out surveys on how they played with Lego and other toys. I took that, I made an Excel sheet for them. They did all the data entry, and then I created a Power BI analytic, and my boys presented with me to Lego on how they played with Lego. So since then, they have loved Power BI. Uh-oh, it's not going to work. This requires mapping, and I think it's really, my internet connection is not prospering. So hopefully this will render when I'm telling this story. So this data set is from a fast food franchise in the US. I don't let my kids eat fast food, so I was at home working on this. Kids walked in and said, Dad, what are you working on? I said, oh, this is McWendy's, so I'm keeping this company anonymous. I said, it's McWendy's data. And they said, oh, Dad, you got to take us. and because they can't go, so of course they really want to go. And I said, no, not a chance. But my older son, who was really working, it said, come on, Dad, for market research, you got to take us. Which I thought was pretty good reasoning. So I succumbed. Now let me try and get it functioning. I'm going to hope this functions when I filter down. So I was looking, I found the one closest to my house. I'm going to hope that I can find it now. So if I type in, the guy whose name was closest to my house, his name was Patrick David Farmer. So if I type in Farmer, it's going to give me Patrick David, and maybe it will render for this smaller map. No, it's not rendering. Okay. So this was kind of cool. So I'll explain it even though I can't show it. Patrick David had, I think he had 11 different franchises. So if I change this to a column chart, I'm going to bring in the number of stores right there. Okay, and then when I sorted by the number of stores, so Patrick David Farmer had 11 McWendy's restaurants. I thought that was pretty amazing because when I imagined how this business worked, I thought someone might have 2 or 3 restaurants, but not 11. 11 seemed like a lot. And he had his restaurants in Seattle. Most were in Seattle, but one was in Wenatchee, which is about 100 miles east of here, and the other was all the way down in Portland, Oregon. So this big geographic spread. So then I thought, well, that's pretty cool. I wonder if there are other people like Patrick. So then when I sorted by franchisee name, I saw that Patrick when I sorted by number of stores, I saw Patrick was not unique. This guy, Glenn Mueller, had 193 stores. His were in Alabama and Louisiana. The next person, Susan Graves, and it's much cooler when the map then shows, right? When I have Susan Graves, she had 103 stores, and her area went from north of Fargo, North Dakota, all the way down to Charleston, West Virginia. Right? So this huge spread across the country. And the coolest guy was Dariush Hosseini. When I click him, he has how many? Slightly less, 100 stores. He was Mr. Southern California, going from Tijuana up to north of LA, right? So this really interesting business. The CFO was coming in, I'm a finance guy, right? So I wanted to produce something that would be usable for the CFO. And so I envisioned, and this was sales data, so an all-up sales dashboard where he could see sales metrics about his business, but then be able to very quickly drill down to identify one franchisee, because the success of the overall company hinges on the success of individual franchisees. So when I built out this dashboard, this is what I came up with, and again, there's a map down here, but key metrics, so I have sales, year-over-year sales, margin, and sales per store. These are dynamic, so they change color if they exceed a certain variance. And then this drill-down path to go down in deeper and deeper into the data from a geographic perspective. So I select Southeast, and now we're just looking at stores related to the Southeast, so all the metrics are changing. If I come into Georgia, now we get down to 24 franchisees, 184 stores. The biggest city in Georgia is Atlanta. And so now I see these 2 guys, Mike and Joseph, so I'll select Mike. So now we're just down at Mike's stores and see that Mike is down, he's below average in year over year, on average in margin, and above average in sales per store. Right? So really, I can get to a lot of data, and then this map, I would be able to select an individual store for Mike and be able to see that store performance. So it's unparalleled kind of mobility up and down through your data to do data discovery very, very rapidly. So I need to end now, but thank you very much for having me.